Or
So I'm gonna have to distribute a different link because for some reason it's not. I can through the same software I can schedule the stream, but then when I actually go live, it takes me someplace else.
Annoying.
And I don't know how
Okay.
to. Well, I would say the last time I edited the settings of the live thing, it completely got rid of all of my scenes, which was annoying.
Yeah.
So
Yeah, that's pretty lame.
so let me share this link. Copy link address. All right. New. I'm gonna post this in the Music Box channel.
Wow, sweet.
all right. Got
New link. Got it.
Okay, the
Yeah.
installation program has enough information to start the 3D experience R221
Okay, I'm
X
looking at the stream.
hotfix 4.5.
It's looking like it's working.
What is this?
Yeah, so I had that hotfix go a couple days ago, and it was the kind of thing where it would just upload and then just be spinning like forever, and then it would be like 100% done, and then nothing would be happening. It was really a pain in the butt. All right,
So like SolidWorks.
I guess it's like there's nothing you can do. You know, if you hit terminate early, it's like, are you sure you want to like finish the installation? And you're like, it says and then connect to it. We're gonna be going through. We're gonna be doing the Music Box CAD again. We're gonna start over from scratch again, because what I really want to do, one of the things I really want to practice, well, the point of this project really is to practice using SolidWorks for the MMX project, the MMX touring the phase 2 version. And so far, everything I've done in SolidWorks on this Music Box would be a disaster.
Garbage and trash, and that's why we're throwing it away.
That's why it's pretty much garbage and trash. So, in particular, I want to work on, and it's good that we have Eric and Andre here. Eric and Andre are long-term team members. If anyone watching this doesn't know them, I don't know why you'd be watching this and not know them, but just for the sake of being complete, Eric is our master assembly guy, and Andre is skeleton master. That's kind of
Skeleton man.
Which, Tim?
What?
Which one of us is which?
Oh, so Andre is Skeletor. Andre is in the middle. Yeah, Andre is the American, and Eric's the Swede. We put Swedes on top, and then both Andre and I are both from California, which is why we're both wearing matching colors.
Yeah, so you got to be color coordinated.
Yeah, it's Burgundy Day in
what
California.
I was told anyway.
Yeah, pretty much.
Okay.
And the for the MMX, we have all lived through this kind of, I don't want to say nightmare, because I do have real nightmares that are much worse than what we're talking about, but it's something of a nightmare, which is that how do you organize the CAD file that way, and how do you have it so that things fit together, and if you make one change to one part, it doesn't all of a sudden break everything. And the answer to that is to do top-down modeling. To start with a skeleton sketch is what we're talking about. And basically model everything with respect to this overall blueprint layout, so that if you do make a change in one place, those changes are kind of kept with that thing and it doesn't break the entire assembly. We really don't want to have to go back and redo the touring version of the MMX if we don't have to. So having the thing be parametric and have it be driven from a set of numerical constraints that we have decided on beforehand, we want to take a long time to do that, and to do it well, so that the design is flexible enough that we can make changes, and robust and logically well enough designed so that when we do make changes, it doesn't break everything. Is there anything that we want to add on to that?
Sounds good to me.
Sense. And also like understand what the core design like constraints are. Like you need the paper to go through this part, and so everything's defined off of that.
Right.
That kind of information should be in the skeleton, ideally.
Right. So what I've done in preparation here, I played around this a little bit. I actually had a little bit of not a panic attack, but I did have a little bit of a oh crap moment when I realized that I made this whole list of parameters for the music box, and then I realized that that importing them into SolidWorks was not as easy as I thought it was going to be at all. So we're going to go through this. We're going to go through this together. But first, I want to talk about kind of the background. So 2 weeks ago, we started sketching it. We had a general conversation. Last week, I had designed the paper pulling mechanism, and we started trying to figure out how we want the paper pulling mechanism to fit into the overall assembly. And what we really kind of got to is that the paper pulling mechanism was this set of 2 plates with rollers in between them. The motor would be part of those 2 plates. And I'm not going to open it up because that's just a distraction. But then there were going to be vibration isolation mounts on the outside of both of those plates. Basically, these sandwich mounts for McMaster Carr that are vibration isolation things. And that means that the width of the paper, no, Jorn, I won't open the disaster again. Thank you.
We don't look back.
Yeah, no, we never look back, darling.
Except if the dimensions are back there, then we look
back. Yeah, exactly. So we have the width of the paper, the width of the plates, and then the width of the vibration mounts, and that is a stack of components which is actually going to dictate the width of the box. So we can't start with parameters that say, hey, the box itself is going to be this wide and that tall. The width is actually driven by some other constraints. So that's kind of what I've done here is I tried to capture all of the different kind of primary driving constraints that we could, and then we'll start with that. And what I've done is I started off with a couple of things like, for things where there's a little bit of need to be a little bit of wiggle room. I have a general overall tolerance for fit. When the paper is going through things, I have a general tolerance figure for the dealing with the paper, which I have here as 2 millimeters, and the paper width is 70 millimeters. And then I've kind of color coded these.
Wait.
Yeah.
Can you go deeper into the paper tolerance?
Yeah, so that's basically, I'm thinking the paper is 70 millimeters wide, and we confirmed on the Discord stream that the paper that's sold for both the 30-note and the 20-note music box are both 70 millimeters. So,
okay. So that's...
if we're going to make a channel for that paper to come through, it's going to be I've given it 2 millimeters might be too much, right? But if you have the distance between those rollers exactly 70 millimeters, it's going to rub on one of the sides at least, right? So I want to have a fit tolerance that we can play with, and I want that to be a parameter.
How big are the holes for that go in the paper?
That's a good question. I don't know.
And how thick is the paper?
Because the holes are there's a tolerance in where the thing.
Yeah.
I don't know what you call those. The hammers.
Yep. Well, the reason I didn't specify. Well, so the music box itself, as it's designed, is going to have the correct tolerance, right, to line up the holes, right. This is really on the take-up reel. How wide do we have the plates? I actually don't think we're going to get the thing off track if we set the tolerance there too much.
That's true, yeah.
But for the primary stack of the plates in the paper pulling mechanism, the dimension that's between those 2 plates literally is the width of the paper plus some tolerance we give it, right? That's that kind of primary value for how far away those plates are. So in this case, with these two variables, that would be 72 millimeters. Does that make sense?
Sounds good. Strictly Steam in the chat says, have you guys decided on a motor to use? As you know, I'm building this music box myself and like to know what motor is best.
Yes, we are still worrying about that. I have, and there are many options. Let me get to that. We'll put a pin in that question for a second, because I'm going to get to that in a little bit. you can see I pulled in this is the drawing that came off of Amazon for this music box. We obviously need to get this. I did not do any of these hole mounting locations because A, they don't matter right now, and B, they might change depending on the model we actually get. And then I captured a bunch of dimensions off of the design that we did last year, like what's the center of the paper roll, what's its diameter, and we had already kind of 2 weeks ago we had matched those to some of the actual pictures we have in the reference material.
Mm-hmm.
And then I have a bunch of dimensional things like, you know, how far away from the paper machine is the set of nip rollers, what's the shaft size of the motor, what's the bolt spacing for the motors. And this is the issue with the motors. There's a couple of schools of thought. One is to use a brushless motor, like an RC brushless motor with an encoder, which is kind of the O drive setup.
Mm-hmm.
One is to use a stepper with what's called a trinamic stepper driver, and I've watched every single video I possibly can about those motors, and it looks like they are very quiet when they're running slow.
Yeah.
And so, and like a NEMA, so these numbers here for these motors, this is a 5mm shaft, 22 millimeter. This is the diameter of the circular part in the middle of the motor. This is all basically, I took these, these are all the, from a NEMA 17 motor is the assumption, or at least that, but I've made it parametric so that if we change this, it'll just update in our designs, right? We can change these parameters.
Yeah, and you can just make a bracket for the RC motor that fits on the NEMA 17, you know, outline.
Yeah.
I think that's what the O-Drive people do.
I've seen some of that, yeah, especially for handling the but that is, I mean, that's useful if you have a bracket where you already have like a bolt pattern for a NEMA 17 motor, right? We're gonna be making this mounting plate ourselves. So all I really want to do is to be able to put in some placeholder numbers, have them be parametrically driven, so that way if we say, you know what, we're going to use a different motor, it's going to have a 19mm bolt spacing instead of a 22, whatever, we just update that and the whole design updates itself, right? I think this is a perfect reason and kind of use case for a parametric design. We can change that. We don't have to stop the design of the skeleton because we haven't picked the motor yet, right?
Yeah.
And then the last kind of evolutionary thought here is between these pulleys. And before I had there be a gear reduction in the pulleys. But actually now that I've looked at the trinamic, like if we do a trinamic stepper motor, I think there's going to be plenty of torque. We're still looking to measure that torque, but I think there's going to be plenty of torque. And they make more noise when they go faster. So I don't think doing a speed reduction with the belt is going to happen. So what I've done here is I have pulley 1 outer diameter, pulley 1 working diameter. I have these numbers here, and I've basically set those to basically
like
themselves.
A speed increasing belt.
Yeah. So wait, and we did throw your clear path servo in the trash, right?
It's I mean, we're not going to be putting it into this drawing for sure.
Yeah.
I don't know that it's permanently in the trash. There's still, I think, a use case for it, but it's, I would say this, and this is me coming from me wanting to stick to what I know, which is that in our Arduino with a potentiometer as an input, a step and direction output to a stepper motor driver to a stepper motor. That's something I know how to implement. I've never done. I mean, maybe the O drive is the right solution, and maybe we need to dive into that. But for right now,
drive those with step and direction also, just FYI.
Yeah, well, and you can drive the clear path ones with step and direction too.
That's true. Yeah.
Right. So there's a stack there of the drivetrain that we need to figure out. But my thinking is that with all the vibration isolation that Martin's already done, or Martin did with the first thing, if we have a trinamic with a stepper, that is a low cost, easy way to go, and I think we can kind of assume that as a pathway, and then if we're wrong, we change it, right?
We also have a comment from Yuran. We can use a servo to drive the tank treads that we're gonna put under it for transport.
Yes. Yeah. Yeah.
So it
Is there
drives
like a
around
Nerf
the
gun on top
stage.
as well?
Yeah. Drives around the stage while playing.
Potato gun, I think, is probably.
Actually, though,
Yeah. If
I mean,
if you assemble this in the United States, it has to be a potato cannon. It's kind of that's the Murica thing to do.
True.
Yeah, I think like building those are illegal here.
It's illegal in most states here as well. Probably definitely in California.
Awesome.
Yeah.
In Idaho, probably.
Probably
Well,
not.
everything is banned.
Probably not.
Everything is known to the state of California to cause cancer, right?
That is. How do you know that?
No, I've seen it on some
Yeah.
imported products.
Okay, yeah, it's
some coffee
Oh, a
table or
t-shirt
something.
cannon. That's a great idea.
yeah, t-shirt cannons are legal, but they are velocity regulated, I'm sure.
Hell.
You know, it should be like a Wilson launcher, though. You know, or maybe you make a foam plug that has a Wilson burned into the face, and you shoot those out like giant Nerf bullets.
Plywood Wilson.
I'm imagining like
launch
the
Wilson.
evil mastermind version of Martin who has like Wilson shaped like shurikens, and then he like throws it.
Shurikens, yeah.
Wait, I've got to design that now.
Just like that Wilson smiley face, but like blood is slowly dripping down over it.
All right, so that is the basically the parameters that I did. And then one thing I did is I exported that into. I thought that would be able to import that into SolidWorks as a CSV. Turns out I'm wrong. There's this other format, which is a equation list or something, where you have a name in quotations equals and then a value. So I exported that whole list of parameters into this, and then in SolidWorks, I know that we can populate in the equations field the general variables field with that. I tested that. The question,
is it
though,
going to work if they have spaces and stuff in there?
Yes.
Okay,
You'll see. We're going to do that, right? This is going to be part of our instructive content for this stream. So we'll do that together. But the question I have, and this is a question for you, Andre, is where do we start? Do we start with a part and make a skeleton sketch in a part and then bring that into an assembly? Or do we do what we did last week and start an assembly and have a sketch in the assembly as a skeleton?
Yeah, this I have no idea. I haven't really spent much time screwing around with SolidWorks.
I would do as David said and have a sketch to begin with in the assembly.
But is that sketch in a part or is it in the assembly? Well, actually, you know what?
Assembly.
In the assembly. Okay, so I'm going to go.
It's what you start the assembly file with.
Yeah. Well, the other reason I think that should be the case is that the global variables that we are pulling up, I think, are things that we want individual parts to be able to pull from those, right?
Yes.
So if the global variables
says at my work, sorry, go ahead.
No, what were you gonna say?
Joran Vogel says, in my work, we make a skeleton sketch in a part and put that into the assembly. I like that idea if it can work, because then you can open up just that part and not have any of the other stuff, which seems like it could be a useful thing.
Oh yeah, to keep the assembly clean. Yeah.
Yeah. Well,
and that's kind of the plan behind the way I did the skeleton for the MMX model.
Okay. You didn't draw it in the master assembly.
I didn't draw it in the master assembly file. I drew it in a separate part.
All right, so let's do that then. Let's cancel this. We'll do this in a part. New part.
I'm just gonna go ahead and make throwing star Wilson.
Is that parts and assemblies aren't different, so it doesn't matter.
No, they're just files.
But...
All right, so now I've gone to equations, and I have where the heck did I put this thing? Where did I put this? I need to find.
My installation's stuck at 97%, by the way, so that's great.
Yeah, same here.
Is it?
No, wait.
Somewhere that I'm missing?
A restart is required to complete the SolidWorks install. A question. Is it 2,718 out of 2,718 for you too?
Yeah.
Yeah, that's what I was telling you guys. I had that for a while. See, now this is all of my equations coming in. See that?
Sweet. Okay, that's good.
So
really good.
those all work. So now we have basically all of our parameters in, and I do think that I do think that the intent of this is to have a document you can make and have it automatically rebuild when you change that text document.
Yeah.
Which I don't plan on doing, but I guess we have that.
No, but it's mostly for like when you send this to economy to pump out 500 different part orders.
Oh, so you would have
Yeah.
a different text document for each variant of it?
Exactly.
Interesting. All right. Well, let's make our skeleton sketch. Actually, let's save this first. Box skeleton.
Configuration.
Stream 1, stream 3. This is our third stream.
Is it every stream that you're gonna be making it from scratch?
Until we start doing it right. Right? I mean that.
No, we're just gonna have a final 10-hour stream where we do it from scratch.
Jorn says you can make the properties configuration specific. Oh yeah, okay, yeah, that makes sense.
Yeah.
I was gonna say maybe the goal is to just do it from scratch every time, but we get better at it, and so we get farther every time. And so when
That's
we can do
basically
the
how-
entire model from scratch in one stream, then we know we've achieved our goal.
Right. Right.
That's how every CAD modeling
Yeah.
works like.
Well, that's kind of been my.
You're only allowed one stream length to do it.
Yeah. Well, 2 hours. I mean, how about this? If you've drawn something in CAD enough times, and you have all the constituent parts kind of already developed, then yeah, you actually probably could.
I'm sort of mad at I'm still sort of frustrated at the Wilson recreation Martin made. That's up online.
Okay,
It's not.
talking about?
You know, the one you can download on the Vintergatan site.
You're still
There's
mad.
a CAD file for Wilson.
You're mad about a CAD file.
Yeah, because it's not accurate.
Mad about CAD.
All right, so I'm going to lay out some of the first elements here. This is our music box.
Looking good.
It's wrongly defined.
And now I have this is an interesting question. I was playing with this, and you guys will probably know. So let's say this is my paper roll offset. If I type in P, paper roll center X offset, that's at least descriptive enough to me, right? The center of the paper roll, the X offset, where that center is, right? I do that,
looks good.
And I hit yes, and it gives me 150 millimeters.
That's good.
Is that dynamically linked?
No, you have to do equals to. I remember this. You have to do. You have to say explicitly its equation.
Oh, so I hit equals and then I hit this one. Oh, and that's actually easier to look up too.
Yeah.
I knew you would have. I knew you would have that. Oh, see, there you go. All right.
No. Okay. Put the variable in. Yeah. No. Look
now. It's linked because it's got that little. Yeah. This is good.
Yeah.
Paper roll center Y offset. Yay, we're parametric and stuff. That's hot.
Tim relearned SolidWorks.
Yeah, I mean it's been a while, right? So paper roll working diameter. I have outer diameter too. I'm gonna put in both of these.
Which one's the outer diameter? Is that like the edges?
Yeah, so there's gonna be a flange on the side of the paper roll, right? So I give it a 10 millimeter difference.
The mathematician in me wants to call those two variables px and py.
Well, mathematicians don't understand that variables can be multiple letters long.
Well, I mean,
they have indexes.
Yeah.
It's dumb. I mean, I understand that it makes sense for, like, if you're trying to write, like, 70 variables in a tiny space that you want them to all be one letter. But for this...
Yeah, I mean, my default is to think that the parameters should be descriptive.
Yeah.
Right? They should be self-explanatory.
Yeah. I know a lot of programmers who will have very abbreviated names for variables.
Yeah.
Because they come from that old school of saving memory space.
Right. Or if you have a
Right.
database where the you're constricted to 16 characters or something.
Yeah. Hold on. SolidWorks is doing something.
All right, equal. I don't know what I call this. This is
Executing application.
Note mechanism length. So look at that. We already have a fully defined sketch here. This is amazing.
Hey.
That looks good.
Now one of
the take-up roller.
Yeah, let's see. So one of the things that I'm kind of just assuming, and this isn't a parameter, but it's just baked into the way we're going to do it here, is that this dimension here, this 18.9, that's called platter to base of the note block. So that's kind of basically the level of where the paper comes through. And so this line here is basically, at the origin, it just has to be an understanding that that origin is the plane of the paper coming through the mechanism. And that the nip roller and that was the idler roller. This is the nip roller. Those are both also in line with that. So here we're doing stuff that is
great. SolidWorks should now be launchable.
All right. That equal to idler roller working diameter. So that's the actual paper diameter. I have bad news on these rollers, by the way.
Oh, what about them?
They do the rollers, the off-the-shelf rollers that I had intended to use are not available in metric sizes on the MasterCard.
I was just about to guess that.
Yeah.
God damn it.
Yeah. So, it's drive roller. There we go. Drive roller working diameter. So I didn't call it nip. I guess. Oops. Darn it.
What is the difference between? Oh, I see. Because the shaft is the thing that comes at the end. Yeah, that makes sense.
Yeah. Darn it. Why do I keep? I think I equals. I need to hit.
You hit enter afterwards?
Yeah, I didn't hit enter.
Oh, wait, yeah, why didn't that work? I missed it. Okay, so then you hit the little check mark up top there as well. Yeah. Cool. Yeah, this should... Wait.
So the position of these shafts...
Jordan Osvogels asks, and I also have this question, they're not the same size? I thought we wanted to use the same roller. But
so
this allows us to use a different size roller if we wanted to.
Yes, correct. One of the ideas that we could do is that because there was this this visual feedback wheel, right, that Martin had on the original one. I think the best use case to do something like that, if he's worried about is this thing working, is that this wheel on the bottom is going to be driven by the motor, right? If anything is wrong with this machine, especially the thing that I think that could go the most wrong, which is a lack of tension between these two, then this one could be turning and this one is not. If this one is turning, you know it's good. And this is the idler. This is the driven roller. So the idea would be that we could make this a smaller diameter if we wanted to, because that would speed up the speed of the indicator wheel. Right. So I did define those as two different dimension sizes in case we want to change those.
That's an interesting idea.
And these are the shaft diameters.
But you would still need to do a gear from this to the visual thing, right? Or no, you just drive the visual thing directly from that roller.
Yeah, I think so.
Cool.
Yeah. So from a idler roller shaft diameter. So I'm assuming 5mm shafts on these. We're going to go as metric as we can.
Absolutely.
And given that there are no metric drive rollers like the ones I had found on McMaster Car, we do have the option of just making these on a lathe. I do own a CNC lathe. This can be done. I'm not too scared of that.
Tim, you remember Martin's comment about the
I
fact
have no
that
friends.
I have no friends with a metal lathe.
Yeah.
The stream
is okay.
Yeah.
Yeah. All right. So am I back now?
You are back now.
So I had an interview with the important interview with the university yesterday, and that happened in the middle of my interview too. That was not cool.
Oh, awesome.
Yeah. Yeah. So still adding dimensions here. But anyway, I was going to say, like, Martin does, the parts I made for Martin, the first parts I made were steel things for the funnels to go into, the adapters for the funnel pipes to lead into, to go back into the machine. And those were steel. And I made those like 2 years ago for him. So
Yeah.
It was only really in the earliest of days that he didn't have friends with the CNC lathe. He has made plenty of washer stacks since then. So I don't know that excuse.
Yeah.
The thing is, though, I mean, he needs that spacer right now, right? So if he, like, I'm sure he could commission you to make him a spacer, but then he'd have to wait for it to get to him, and by that time,
well, he'd also have to commit to those heights, right? And I think,
that's true.
The thing I think is really important that we like all need to keep in mind for Martin is that like this notion, and and he gets caught up in this too, right? He wants the machine to be totally reliable, but like he doesn't need this machine. The machine he's building now is not the machine he's taking on tour, so it doesn't need to be 6 Sigma reliable. It really doesn't. It needs to just make it through a song or through recording portions of a song. And I think that the original Marble Machine, like I think they took 6 weeks to shoot that video, and only
50 days.
Yeah,
if I recall correctly.
Yeah, in the midst of it tearing itself apart repeatedly, and all this other stuff. So if you could make a video that gets, I think it almost has 200 million. I showed it to somebody today. I think it had like 160 million views on it. Anyway. I do think it's going to be healthy for him to relax a little bit about absolute reliability of the studio version. Get into the mode where we're, he's making an album, recording stuff, getting ready for a tour, and let, the incredible army of engineers we have in this team do all the rest of the worry for him,
Yeah, it's hard. I think that he doesn't want to release he doesn't want to let us design it, basically. I think that's the challenge that he's working with, and I totally understand that because it's his baby.
Right.
It's his big metal baby.
Also, he needs to make the marble drops.
Yeah, he
before
does.
he can play any songs.
That's true.
And I'm excited to see that happen. I think it's going to be soon that he does that.
Yeah.
All right.
Do you guys remember what the first design mistake of the original Marble Machine was?
Marbles?
No.
Yeah.
The first thing
thing.
they did. Well, the biggest, I think the biggest design flaw they did was building it 150 centimeters wide, in a room where the only doorway was 140 centimeters wide.
Sounds right. That sounds right.
Classic monkey reaching into the jar to get a banana problem.
Yeah.
Yeah.
Seriously. All right. So we have the motor shaft. We have the motor face.
Okay, but the motor shaft doesn't need to
starting
be
to look
vertical
like
with those things, right?
It doesn't need to be, but I am designing it that way.
This
is there a reason not to have
look
it?
Like...
No, I can't. Yeah, I can't think of any reasons for it right now. Uranos Vogels, and I agree with this comment, says it might be easier to design a universal spacer with grooves at certain intervals so Martin can cut it to length easily. I was actually thinking of if you could order like a plastic tube, with like a hole in the middle, and then he can just like hacksaw it.
No, you know what the perfect application? That's actually the perfect application for additive manufacturing.
Yeah. I mean,
I print
making a cylinder. I don't know, man. You can buy cylinders.
No. I love 3D printed spacers. I use them in all my projects.
But can you make them durable?
Yeah, one problem with 3D printed
you can.
Spacers, in my experience, is that the plastic does get squished if a lot of force is put under it.
Yeah, if it's
a bicycle,
if there's a lot of forces and
wheel
there's a lot of heat
for it.
Yeah,
and like over time they definitely get squished. I mean, we made them 100% in full PLA, but like.
Oh, you made them in PLA. That's It's one part of the issue. Yeah, so a design I inherited, they were holding up this heated build plate, which got
That's not
like
gonna work.
This is
it
the
could warm up.
old-fashioned way to put 3D printers together. Yeah.
It could warm up to 120 Celsius, and so they were using PLA brackets for mounting that.
Hmm.
Yeah.
Yeah,
Wait,
that's not
hold
going to work
on.
very well.
You hit the cancel button.
Yeah, so this is wrong. So the spacing between the bolts on the side of the I think this is 23 millimeters. This is the intent of this and also this name of this equation is doing something weird. I think it's looking for a variable.
Should we reconstruct Wilson and SolidWorks, or is that
annoying.
like heresy?
Aaron Vogel's posted in the chat a link to a DigiKey part, which is a spacer like cylinder with a hole in the middle. Pretty sweet. How long is it though? How long is it? Length overall 10 millimeters. That doesn't seem like
Which
a very long
chat?
spacer. I mean, this is for probably for like circuit boards. In the Discord chat.
Oh, there.
But it would be nice to get one of those. Yeah, I like the idea of this.
Yeah. So which plastic is this?
It appears to be.
Is it Teflon?
I thought I saw it say nylon.
Oh no, it's nylon.
Yeah, nylon.
Yeah, awesome.
This is like a little standoff, right, for a circuit board.
Yeah, it looks like
Hold
that.
on a second, let me find
Well, actually, no. Diameter outside 12 millimeters, so that's pretty decent.
So, in what chat is that in?
But yeah, it was in the Discord chat.
Oh, M8. No, that's not for a PCB, Andre.
Which Discord chat though?
Music box.
CAD Team Music Box.
M8 is like
yeah, if you post
quarter inch
in the YouTube chat, maybe it would be easier for us to click on it really quick. But
yeah, oh, I see this.
Andre, it's for M8 screws. And M8 is like a quarter inch, sort of.
Yeah.
So, I have to embarrass somebody really quick. You guys ready? This is a buddy of mine. This is Sean Ailing. Say hi.
Hi.
So he's a
Sean.
He's a PhD electrical engineer. Friend of mine. We're working on. Tell them about our project.
Which one?
The calendar project.
So it's an electronic display, kind of like what's on a Kindle.
An e-ink display.
For your desk. Cool. It's essentially a desk calendar. Instead of having the paper you rip off every day, it's images you load to it, and then
like a Farside calendar is the one I want.
Yeah, that's what I want. So.
Yeah. So we're making a desktop e-ink display thing. Yeah.
Okay.
Pretty cool.
Yeah.
So you're.
I get to hang out with a lot of really smart people.
Oh yeah.
That's one of the perks of my existence here.
Yes, we share our kitchen with another business incubator, so during lunch you get to hear a lot of crazy ideas.
Yeah, there you go.
And also a lot of naivety, but I mean.
Oh.
That is required to and take such endeavors, you know.
Well,
a lot of what? I missed what you said.
Naivete, he said. There's a certain level of irrationality that is endemic in entrepreneurship, right? Because if you were just going to be betting on something, you might as well bet on GameStop stock. You know, I mean, like at least, you know, when you make a random bet in the stock market, the odds are actually in your favor because the market itself goes up, right? When you start a company, the metrics are like 90% of them go out of business within the first 3 years, something like that. So there is a level of optimism which is irrational that's necessary for being an entrepreneur, and there's no way around that, really. All right, I just realized
when you're presenting your project to people, you got to tell them that it's going to be like the thing, right?
Oh,
you
yeah,
have to say that.
Yeah. Sprinkle in all the
after you
buzzwords,
say
man.
enough, you will start to believe it.
I've been acting as a technical advisor for a ton of entrepreneurships through
That's
school,
weird. It's not giving you a thing.
and
Yeah.
they do a lot of buzzwords.
You have to do it.
Oh, you mean kind of like the 3D experience platform with the collaborative business?
Yes.
Yeah. So
Collaborative business innovator.
Right. I just realized that this is where the NEMA 23 motor, all the NEMA motors, they have a face that has to be inset into the mount. So I want to actually add in my fit tolerance, which is 1/4 of a millimeter there, because otherwise it would interrupt. So I actually have now 2 of the global variables in one dimension.
Yeah, sounds good.
Yeah. So that.
How are you making these? Are you milling these parts?
Yeah, this would just be aluminum milled out. I could, with the CNCs I have.
1/4 millimeter is pretty big.
It is pretty big.
Doesn't matter. This is just the face of the motor. Also, the motor is gonna, the mounting of it is gonna be slightly oversized.
Crap! You know what though? I also just realized that there is tensioning the belt is going to be done via slots. So all these things I just drew as circles.
Oh, you need them to be slots.
Yeah. I'm just going to add that in, and even this guy right here.
Yeah. Classic motor slots. You gotta have those.
Yeah.
So that guy.
Yeah, I guess.
Motor slots.
Oh, the problem is
actually I have to do.
It's bigger
that reminds
than
me.
than the circles.
I should probably do some FEA on this motor bracket I designed a while ago. Because I haven't put a motor on it yet.
All right, so we need a new global variable now, which is going to be the slot. What do you call that?
CC. So the slot length.
Slot length, yeah. Tools, equations.
Yeah, make the slots equal. Bubbles in the chat.
Slot with a double T is also Swedish for
I
castle.
did use the slots equal thing. Thank you. Slot. Slop.
Slot. Get your slop.
Do I have to?
You have to put it in quotes, maybe?
Yeah, I do.
Why is it like that?
No idea.
That's how it works.
I hate a lot about how this works. Alright. Okay, that's good.
Yeah.
Why do you have to put it in quotes? Doesn't it know? Come on.
No idea.
No, I guess it's like if you want to have a global variable named pi, for example. So you put it in quotation marks, and that differentiates it from 3.141529 on and on.
But you shouldn't.
No, you
set
shouldn't.
Your variable to be equal to pi.
No. But if it should name the Greek letter pi for some reason.
But I like pi.
Right.
Yeah, pi is nice. Although tau is in my opinion is superior.
Can't be eaten.
All right, so I actually think.
Wait. Okay, so the slot for the top roller, the slot also needs to exist, right?
Well.
No, you don't have to adjust the belt in both ends, right?
Well, no. So there's no slot in this one, but I think you're talking about this one. When we do
one can be static.
When we do this one, I'm going to mount it in a tensioning block in and of its own. So we're actually not going to draw this roller in this place.
Yeah, sounds good.
Yeah.
We can draw it there and then put it in an assembly, right? The thing that moves.
Yeah.
Oh,
no.
I didn't know that. You don't have to go into the table to create variables, Tim.
Oh, I don't. Oh no, you can hit it.
Yeah,
you can do it through the thing. The whole thing. The whole thing is that I wanted to come up with the variables first, and then do it.
Yeah.
Because I do think
short.
Well, I mean, this is an example, right? I mean, we found things and we added to the table. I do think we're going to be doing this exact same process. I mean, and hopefully when we go through this, then we'll find that this works, right? The point of doing this is that we're going to figure out like, oh crap, I should have done it a different way. and then we'll have done that in this sample project before we do it on the MMX, right?
Why is it blue?
Because I haven't figured out this dimension, the belt to belt.
Gasp.
So, well,
Blue line
let's
bad.
try adding a new variable, because there's going to be a belt to belt center point.
Oh, wait a minute. Is the slot not aligned to the middle? It looks like it's smaller on top than it is on the bottom.
It might be.
I think.
Oh.
Uh-oh. What?
Fix that.
Fix what?
He's gonna fix it. He'll fix it. I think Eric's talking about the slot thing that I just mentioned.
Yep.
Ooh, a restart is required to complete the SolidWorks install.
Oh, you got that now? Yeah.
So if I hit OK on this, it will restart my computer?
No, it didn't for me.
Alright, sweet.
It's just gonna sit there and load for a little more.
Cool.
That's what it did for me.
So Jorn is saying put a slot between the motor and roller and add a path length instead of a center to center. How can you add a path length for the whole thing?
Yeah, so if you...
There's a curve length dimension, right?
Can you do that for a weird shape? You should be able to. That's the whole point of it.
You should be able to.
Yeah, that's
if I recall correctly.
I think that's a great idea, yeah. But we don't know, we don't have any pulleys drawn on here though. So
correct, but we do have a pulley dimension in our variables.
Yeah.
And it's okay to move the adjustable slots, right? Because we want them to go around that length, right? So the mean of the slots is there. We do have two different pulleys, and actually, should I draw these as arcs and not circles?
Well, can you can just trim them afterwards, right?
Yeah.
But yeah, I might as well do it as arcs. Also fix
that is something
the motor faceplate thing.
Have you guys noticed how SolidWorks does like trimming remarkably well with preserving constraints?
Yes.
Because Fusion just
it's
freaks
better
out.
than Fusion.
Yeah.
They probably patented it
out.
or something so that Fusion can't use their algorithm for that.
I know I would.
Yeah. I mean, I'm sure the reason why SolidWorks exists at all is because they've patented basically everything that is.
Yeah, they bought everything and patented it. Although I did find out that
did you hit
Fusion's CAM environment is the same as SolidWorks.
Right. Yeah.
Well, because because it's the best, and Autodesk bought HSMWorks. Yeah.
They bought all HSMWorks.
Yeah. Okay, so this is pulley 1 working diameter. Let's see, did I make a pulley 2? I didn't make any variables for pulley 2.
Gasp.
Okay. Now is the chance.
It's pretty big. All right, so how do I... Yeah,
okay, that's good.
Divided by 2. Thank you, Jorn.
Yeah, no, the Wilson CAD file is off by like 1/4 millimeter in some places.
Oh man,
it's not good.
All right, so how am I going to add it? Let's try to add a new equation here. So this is going to be pulley 2 working diameter. Is this how you do it? And it's going to be equal to 15 millimeter.
Yeah.
Let's see, what does he have to say? I wasn't paying attention.
Tim.
Yes.
You're adding a radius, not a diameter.
Yeah, I know.
Oh, he fixed that already.
Well, on the bottom one I did, yeah.
Yeah.
Thanks, Joran.
I think this is not going to work because that is just... Maybe just type it in here. Do a where it's in the value field. Type it with quotes in there. So cancel this because
here.
Yeah. So then you go into the into the value field. You do equals quotation marks and type a new thing.
Yeah.
Okay. Equal to pulley 2 Working diameter. Create a new one? Yes. Oh,
Yes.
Nice. All right. So, of course, now... Oh, I didn't specify how big it is.
Right, now you type it in, I guess. Would that change it? I wonder.
Well, let's see if it shows
Would
up
that
here.
change it?
Fully to working diameter. So, 15. Oh, here. Yeah, I did.
M8 by... Hey, I actually... Göran, I actually need something akin to those aluminum spacers.
Okay, all right, Tim, you gotta fix that slot.
Oh, let me fix this one first.
No,
this didn't save me any time because I still had to go back into the table.
Yeah.
Andre, you gotta stop. We've gotta stop background. Backseat drafting.
Well,
that's the whole point of this.
That is the whole
What
point.
you
Of,
can
yeah.
do is you can type in the value, then press enter, then erase the value, then do the quotes thing. I don't know if that's the way you do it, but
Well,
that sounds convoluted.
let's figure out how to get me how to constrain this. How do we do that? How do we do this total path length thing?
Yep. Okay. I don't know. Click on the oval or the not the oval. What am I talking about? The belt path. Click on the belt path.
I have it selected.
You just what if you click
Smart
on
dimension. So Yoran's coaching us through it. Path length dimension. Look at this. Look at this right here. I didn't even know that existed.
And that would have saved me so much headache.
This is great.
In Fusion, if that was a thing.
Okay,
wow, that's
beautiful.
Yeah, Lauren, Yoran, you win first prize. You win the stream today. Let's say that's 150 millimeters.
Yeah,
that's beautiful. All right, now
sadly you can't.
Andre, I'm gonna fix your. Oh, dude, this is disgusting. Oh, you know what? That's not the oval. That's my path length. Ew. SolidWorks didn't like that so much. It like threw itself out of its sketch.
Oh my god! Why? Why did that happen? This was a regular slot, right?
No, this was the one that I made for the belt. Somehow the all the tangent things didn't get made, or they got undid.
Yeah, it's annoying.
Oh.
Don't you love it when tangent constraints are like, nope, and then they just invert your entire model?
Whoa!
Yeah, well,
whoa.
they're still tangent, right?
Oh yeah. It's
wait a minute.
Malicious compliance, like what you want?
Oh no, this is my slot entity. My slot entity got corrupted here.
This is what I'm talking about. Yeah.
That's circular.
I didn't see you do it. Whatever. Just make a new one.
That was disgusting. All right.
That's weird. We didn't screw it up. I don't remember screwing it up.
No.
Okay, wait.
SolidWorks screwed it up.
Sorry, these are equal radius, right? And then the length of this side is slop.
Yeah, because that circle's already bigger by your thing.
Yeah, so I think the thing that broke was me breaking that thing. So this line here, I love this path length dimension. You know how they have like, you know, all the real cool kids on who are doing streams, you can like give them like money to like make a comment. We need the reverse for that. Like someone gives a comment and it's like, you just earned $5.
That would be interesting.
Yeah.
That would be interesting. Well, normally what happens is there's so many people making comments that you only read the ones that give you money, and so then their reward is showing up on your screen.
Yeah.
Well, yeah, I know. I'm just saying that there should be a reverse of that, right? So you can like.
Yeah, I agree. There should be. I think that would be great.
Yeah. Yes.
People to give you helpful suggestions.
Yes, Yarn. You're checking an accounting number. I have a friend in Nigeria who wants to send you some money too.
Yeah, that's right. Make sure to post your social security number too.
Do they have that in Europe?
No, don't actually do that stuff.
We have a thing called a personal number.
Yes. All right. So
which,
what am I?
I mean, it's sort of equivalent.
Yes. Yes. El Principality. He called. All right. So now we have. Let's see. Do I have? I do. So these are the sandwich mounts. The ones that we were looking at last time were like really big. I found some that if you go down to M4 in size, you can get some. The height is still in imperial units, but we can use metric threads. So you can see this the selections I have for these things. It's a metric M4 thread, metric thread. I don't know why this should be redundant. Anyway, half an inch is in height. And there's a capacities that you have. There's the sheer, less than 25 pounds, 25 to 49. We do this thing does not. The whole machine is not going to weigh 25 pounds. So, so I selected those, and that gives me these guys. And these are of a reasonable diameter. So these guys are 5/8 inches in diameter, and they're half an inch in height. So, did I put that into my parameters?
So for Throwing Star Wilson, should he retain the amount of teeth?
Are they metric
teeth? The teeth are the most important feature of Wilson, I think.
Yes. Is there a metric ISO standard for Throwing Star teeth size?
I'm pretty sure.
Are there any other sites we can order from other than McMaster? I think we talked about this on our chat with Martin that we had, and he
didn't have a good answer for an alternative, right?
No, he's been using like local hardware shops, from what I recall.
Yeah. So I do have these parameters in here, although it looks like I put the thickness, I phoned it in, I just had 12 millimeters, which is not correct. So I'm going to have to change those in SolidWorks. So I'll go to Tools, Equations, Isolation Mount Thickness. What did I say that is? We're going to go for half an inch. Yeah. Cool. 0.5. I love this. You can just say, we can mix inches in our design table. Oh. You didn't like that?
No, but you remember what David said, right? About adding imperial fractions for the meme.
What meme?
No, just for the meme of imperial bad.
Yeah.
So whenever a measurement is not crucial, just make it like 25/71 of an inch.
Oh. Yeah. Yeah, that's I'm not a fan of that idea.
It's pretty mind-blowing that they have metric threads but imperial thickness. Like, why not just make it all metric? You're gonna go metric.
Yeah.
Because like imperial.
I somehow did an automatic relation there.
Yeah, wait, how did you get the thickness of that? That's interesting.
It's lining up with stuff over here. I basically have to go way the hell down here so that I don't accidentally add a auto dimension.
Right.
You can like hit option or something, or some way of like avoiding that, but
yeah, but then it doesn't snap at all, right? If you do that, I don't really know.
Soundboard plywood thickness 9 millimeters.
Well, yeah, you can turn off the snaps, but then you have to turn them back on. It's pain in the butt.
Yeah.
Just temporarily disable them. In like, what is it? In like PowerPoint, you can just hold like Alt or something, and.
Now, here's a question.
Are you using PowerPoint?
I mean, sometimes I do, yes.
I have been on to PowerPoint from time to time.
Obviously, for most of my CAD work, but also for other stuff.
Right. All right, so we're kind of, I think, at the end of where I put parameters in. So, I mean, things like this, right? So we have this offset is driven, right? I think every single, except for this guy. Should we make a universal variable for path length? Probably should.
Yeah, because you're gonna do that like belt calibration.
Yeah.
thing.
Yeah, the tools,
makes
equations.
Sense. All right. Okay, cool. So now it's a 150, which is fine. So now you can just do equals quotes. No, do it in the thing.
What? Oh, you want me to try doing it through the
Oh, you already did it.
No, it's okay.
This is like Halloween Wilson.
Is equal to what? Belt? Is equal to what do I do?
You need quotes. You need quotes.
Oh.
Oh, can you just do another equal sign after that? I don't know, but well, right now it's going to set it to 150 because that's what it was before, right? But
I don't think that's how you do it.
Yeah, it seems not. Maybe you put the value first. Equals 150 equals belt length.
How about we
Two equal signs.
figure that out when I'm not live streaming?
Okay. I mean, I thought the point of the live stream was to figure this
Okay, fine. No,
I mean, whatever. Just, well, my suggestion was that since you already typed 150, that's the value that you want. Then you just change it to equals quotation belt length, and then it will set the belt length to 150.
Like that, Yarn? Or is it... No, that's not going to happen either.
No, yeah, just delete where it says 150 right now, and then...
No, I think it's doing here.
That.
Following Star Wars is like the Dark Lord.
Boom. That should work. Look at that.
So, okay, so I think the problem with this is that you have changed the name of the dimension to path length rather than adding a parameter that is path length. So
no, path length is not the name because it's not showing up in here. But look what I did. When I did it here, it showed up in the dimensions.
Yeah.
Here.
So is that good? Questionable.
I mean, we got it into the design table. We just didn't get it into this global variables thing. All right.
Yeah.
I'm okay with that. We can add that into the best practices. I mean, at the end of the day, right? I do think what we want is that we want all of our key variables to be showing up in this table, right? For some reason, this showed up on my other screen. All right. So as long as they show up here and we can play with this, then I think we're good.
Girl in the chat. Hello.
Amen. So we have this. I kind of think we're there.
Sort of, yeah. This is looking promising.
I think that you should change the path length. Go to the dimension and just type equals quote belt length quote instead of 150. I think that's what you're gonna want.
So in the equations?
No, in the dimension. Just where it says belt length 150 on your design. Not in the equation sheet. And then where it says 150, delete that, type equals quote belt length.
I don't have I have it.
Yeah, that's because you got
it's not in the global it's length. Yeah, we don't have
yeah, but you're creating a new one is what I'm trying to make you do.
Okay, so just hit quote belt length.
Yeah. The stream is a little behind for me.
Like that?
Yeah.
And then equals.
Yep, that's good. Done. No. Just equals belt length. Just equals belt length.
Oh, look at that.
Yeah. So then it is set to 150. Yep.
All right, now let's confirm that.
Should have a little sigma there, but it doesn't. That's weird.
There we go.
Why doesn't that have a sigma?
It's not linked, or is it?
Probably because it's a path length. And then actually, oh, but this is at sketch 2.
I didn't. What? That was so weird.
It's probably because we've messed with it so many times.
He says that's path length does that sometimes. Path length is a special. It is a special.
Well, now that just updated to what I changed the global variable to, so.
Oh, wait a minute. Wait a minute. So that's not linked. So if you go back in there, it's still going to be 170 there. Click on it again. I'm just curious. Oh, yeah, dude. You can't link that one. That's annoying. Wait a minute.
No, I don't know.
Oh, no. It's because you didn't do equals. It's because you didn't do equals. You just typed the name and then it says it. So you have to do equals. For some reason, it didn't work out when you did it before. But you have to type equals belt length here. And then click
but
it.
that is invalid.
What? Uh-huh. Great.
I'm gonna leave it
the
there.
Wrong unit? What?
We need to ship it, man.
Well, yeah.
Well, let's try this. Let's try doing the same thing, because there we had created a sketch with the same name, and so there's some other things we did wrong there, right? It's a
double name.
Let's try to divide. Say this is the bottom of the plate, right? Let's make a new dimension for how far away from the center point of this motor is the bottom of the mounting plate.
Hey Tim, you said that belt length equals belt length.
Right, that's what I'm saying. Let's move away from belt length right now. Right, let's. I think we've corrupted this. Yeah. Right.
This is why this is going to be deleted. That is the reason. Just the belt
yeah.
length right there.
All right, so let's make this a global variable, right? So we're going to hit this, and this is going to be, what do we call this? Motor plate.
Okay, but wait. First, hold on. You want the length to be a value that isn't like 16.35724, right? So I think you should set the value first and then change it. And then it will set the value and change it, enter it into your equation table.
Okay, so there's 30 right now. That looks good. Let's make it 25.
Cool.
All right.
Do you guys want to see Punk Wilson?
In a moment, perhaps.
So, motor plate, bottom, offset.
Let me just give him a wood material.
Create a new global variable named motor plate bottom offset. Yes.
Yep.
All right, well, we have the sigma there. Now let's see if that actually worked up here.
Yeah, looks good.
Yeah, hot damn. All right, that worked. I think we all learned something today.
Indeed.
I don't get that reference.
That's from South Park.
Cool.
Yeah. So like at the end of the episode, they'll sum up like, maybe it's not good to, hunt our friends with Bowie knives.
Yeah.
A very educational show, I get.
Yeah.
That's the joke.
Martin will bring up that meme sometimes. He has at least once. Sitting at a piano.
Mm-hmm.
Oh, okay.
Equals.
Okay, we have Punk Wilson. I'm gonna post him in CAD team chat.
Don't show again.
Oh yeah, you're gonna.
And it has to be in quotes.
Yep.
I mean, Excel is like that, right? Excel does these, in order to kind of like understand that this is not a number, but it's a text thing, right?
Yeah, you have to format it as a string.
From a programming point of view, it does annoy me because usually variables aren't text. I mean, they're not strings, right? So if you have
they're not
quotes,
strings.
it's a string. So that's the reason why I don't like it. But it does make sense because you can have spaces, and spaces obviously make it essential to have the quotes there.
Yeah.
All right.
Bjorn Vogels, the thing is though that the top roller is going to be on this like moving armature because it's going to be like weighted down. So the height of the box actually doesn't depend on the belt dimension, right? Oh no, it does still.
No, it does.
You want the motor to be inside.
We'll design this around a certain belt that we can find,
Yeah.
for sure.
But yes, you're right. The box will be a weird dimension because of the fact that it's all being driven by this belt. Yeah.
The bad news the other bad news I have vis-a-vis McMaster car is that if you look at let's open in a new tab. If you go there for timing belt pulleys, and you go into metric with a let's say timing belt pulleys, sorry. I don't know if it has to be MXL, sorry. Clear all. Timing belt pulleys. I found this earlier. I should have just left it up, but metric. Oh, I don't want that. I hit the wrong button. I don't want inch ones.
Disaster.
I know. So 5mm shaft. There's really only one kind of HTD, and which is fine. And I like that they have a 9mm width. I like these guys, but there is no CAD file for these guys. So
are you kidding?
Wait, really?
Yeah.
No.
What?
Yeah.
That's silly.
I mean, so the good news is it's a metric standard. Should be able to get it someplace. I can get it through McMaster Car, which is good. But I mean, we have the dimension drawing here.
Yeah.
I stopped. I mean, I looked at this up when I was developing all those parameters. But I didn't know if I wanted to be polluting the variables table in for the general assembly with details about this pulley part, right? So I didn't.
Our suggestion though, what about a V-belt pulley?
So V-belt pulleys have they're more you talk about ones that have like adjustable radius, so you can screw in and tighten them.
Well, just like then you could just lathe it.
Oh, yeah. No, the idea with the timing pulleys is that you have much more positive control over the speed.
Right. But I mean, this is not going to be a high load application, so you could definitely have a V-belt of some kind. You could probably even use like those O-ring belts that they have inside of like CD drives for this.
Right.
Maybe.
Yeah,
Maybe.
but I mean, this thing they are $7 each. You know.
Yeah.
The positive control that you get for that $7 is pretty good.
But that's McMaster price.
Right, which is probably high.
Yeah, very high.
Yeah.
Well, lower for you than for me.
You can totally get different size timing belt pulleys if you look in Amazon. I've seen different size ones there.
Right.
So I don't know. Maybe McMaster's selection of timing pulleys is somewhat questionable.
Yeah. So I guess in order to do in order to find the belt, we need to enter this stuff in here. But I think that's a level of detail we don't need to do right now.
Wait,
right?
Is that No, that's not a GT2.
No, it's HTD.
Okay.
And so let me do this. Open link a new tab, and we're gonna do HTD.
I mean, it would probably fit a GT2 belt, but doesn't sound very stable.
Huge diameters for HTDs. I see. This is why you did this.
Yeah. Well, but here, so these are the different belts they have, right? And we can look outer circle millimeters here, and what number did we have? What's the closest fit here? 170.
Yeah.
Right.
Okay.
So here we can get. Let's do this guy right here. Product detail.
Well, you could also
129.
Yeah, can you do a CAD file of that?
No.
Guess it would be pretty weird to do a CAD file of a belt.
No, it's not too weird.
Well, no, you can. I mean, there's a whole belt tool in SolidWorks, which we're not going to
We
play
don't
with
have it.
today. Oh, we don't have it?
We don't have it, right?
Oh, okay.
It's part of Toolbox, isn't it?
It might be. So belt length. What did we just got? We got
170.
129.
Oh, okay. I'm just lying.
It's cold here. I'm gonna go close my window, BRB.
So yes, the comment that that we're going to be driving the size of our plate off the belt is correct, and I think it's fine. That did not update.
Yeah.
So belt length is 129. I think we just screwed this dimension up bad.
Nice.
Hey, let's actually try redoing
that's because you didn't actually link it there because of reasons.
Yeah.
Why don't you set the name of the sketch to be different?
No, I just completely took away that
Just
dimension.
delete it. Seems good.
Yeah, so path length dimension. Come on.
Wait. Yeah, why did that not work?
I don't know why it didn't work. All right, here we go.
It's already the right thing. Okay. And I bet you it's going to be named belt length again.
Oh, path properties. That's
what's
weird.
the problem? Why is it not working? Edit path.
Path. So even though I remove the dimension, even though I remove the dimension, it's now it's still a path.
Yeah.
It still recognizes that it's.
Yep. Okay, wait. So then, if you hit driving right there, you can just type it in right there on the left, right?
Yep.
Tim, Joran went to the original manufacturer and got some CAD files.
Oh.
Yeah.
Wow! Look at you.
They went to the gates.
Look at that. Look at that. Beautiful. Thank you.
The bore diameter is 2, but I mean...
I don't want to do... All right. Good to know. Thank you. Trace Sports. I'm not going to sign in for this right now.
Register for free, Tim. You're basically losing money not registering.
Register for free.
All right. So everything here is black.
Just for measly price of free, give them all of your personal data.
Yeah.
Yeah.
All right. So this isn't too small for this thing. I think this is good.
It's kind of small. It's like the same size as the music box part, which is pretty small, I think. But I mean, yeah, it looks fine.
Well, the original was much deeper than this, right?
Yeah.
So even with that, I was thinking maybe we should try to, when I was looking at it like this, I was like, oh, that's a long distance. Maybe we should try to tighten that up. When you look at this in scale, the original music box is probably 50, 100 millimeters deeper than this. So we're still quite small with regard to that. So it's good. I'm going to actually chowder this dimension. Can I change the overall dimension? Would this update that table if I change this?
No, I think it'll just change that dimension.
Yeah, I bet it won't.
No, but it's still sum of 50. This is...
Oh, actually, my YouTube was 1.5 minutes late.
Look at that. Motor plate bottom offset is now 50. So me changing it, I actually updated the variable by changing that. That's
got to be a new feature, right?
That's super cool.
Doing that before.
I mean, it's a little dangerous, though, don't you think?
Yeah.
Yeah.
Agreed.
Well, the reason I did that, though, is that I want to make places for the isolation mounts.
Oh, yeah.
And the idea was that the side of the music, the way that you put this whole thing together is that there's a couple of, let me center this on the camera. You have a couple of plywood blades that come out like this, and in between those are the aluminum plates for the paper puller. And then in between those two sets of blades are the vibration isolation mounts.
Mm-hmm.
So I'm going to change this to also 35.
So, okay, actually, I have a question. So you wanted to make a skeleton sketch, but this is really just going to be a drawing of the whole thing. I mean, I guess those are similar concepts, but like maybe what you want for this sketch is to just have the points where the rollers are and where the motor center is, and then, somewhere else have all of the motor block dimensions. I don't know what you think about that.
Well, yeah, I mean, the hard thing here is that we're still doing general design, right? To the same extent, to the same extent where it was hard for us to say, oh, how do you keep a really concise timeline with your design when you're designing it? Like once a part's already been designed, you can figure out, oh, I'm going to do this feature, then that feature, and that's the most efficient way to do it. But you've already designed it that way. We're still, I mean, like I don't know how the front back width of this thing yet. We don't know how tall. I mean, we're still doing that primary design. So what I'd like to do, I want to at least keep the skeleton up until we've defined the box.
Yeah.
Right. The overall shape of it in this left plane.
Yep.
And in order to do that, I mean, because this is our primary dimension right here, right? It's the plane of the paper coming through. So that then dictates is driven by this drive roller, and then the center of the drive roller is driven by the dimension of the drive roller. Then there's the belt, the motor to motor thing, and then there's the offset, right? So anyway, you feel me?
Yeah.
Yeah. Although I guess we don't really have to have this as an offset from the motor, do we? That's not really necessary because here I've just been adding. I've just been adding length.
To the motor, but maybe you should do a relative to the roller.
Yeah.
Then, like, the roller stays always in this. Like, actually, the roller position is more fixed than the motor position because the motor can just be anywhere where the belt wants it to be.
Right. So let's make this 100 millimeters even, because that's nice. And I'm going to have this also be is equal to paper.
You can do like design constraints. I wonder how that would work because you can say like I can't have the belt length, or I wonder if you can do this. Can you say like a dimension from that motor center to the bottom and be like, okay, this is a driven dimension, but I want to make sure that you can never have it be less than a certain amount.
Yeah.
Oh, that would be something to have it in an interval.
Well,
just like a design rule check kind of thing.
Yeah.
I know Inventor has that through its iLogic, but I don't know what SolidWorks has.
Yeah.
It's very neat.
Yeah. Well, so here, I mean, we've just picked I mean, I would not have been able to say, oh, 100 millimeters is enough for that, prior to having gone through that thing. But I do think for the sake of the design table, it's better to have this variable here than this motor to offset. I still like the motor center to this offset. But since we're dealing with an excess, I think we're okay.
Mm-hmm.
Hey, who's yawning? What time is it over there for you, my friend?
It's 11 p.m.
Okay, you're excused. This one time. This...
I mean, he also had like a coffee an hour ago, which I think for 11 p.m.
No. Well, my coffee, man, my coffee tolerance is way up there.
Yeah, we've heard you brag before. We're not impressed.
Let me.
It's not something to really brag about, I feel.
No, it's something to I don't know.
Celebrate.
Get help for. That help is, of course, another cup of coffee. I'll be right back.
I just realized I put in this gap here in the wrong place. That is not supposed to be there. This guy is rigidly attached to the bottom of the music box.
Oh, yeah. Yeah, that's right. Because then the isolation is after that.
Yeah. Oh, and this thing... Coincident.
Oh, because you drew the line with something else.
Auto snapped, yeah. But now I got rid of it.
Just delete the coincident constraint. Yeah, there you go.
Well, no. Did you see how I did that? I mean, it listed the auto constraints that were placed on it. I love that.
Yeah. Yep. They need to put that in Fusion. I mean, it's so brutal trying to find like where your thing is constrained. Like you just look at the slight brightness difference in the
Yeah.
thing when you hover over it. I don't know if you've ever done that.
No, I have been there. All right, so now we need to define. This is kind of cosmetic, right? So he has all these isolation mounts over here, and then this edge is floating in his existing machine. I think that's because he wants this whole board to resonate back here and not be damped. So we do need to provide ample length up here, and then this thing has to, we're gonna have to figure out how much, where this.
I think for sound purposes, you definitely want a dimension from the middle of the music box to the edge of the wood, and also from the middle of the music box to wherever it's attached with the vibration isolation mount on the left, because then maybe you want to tune that somehow.
Yeah, so I'm going to call that is equal to note box to front edge.
Because the sensors can be linked to a dimension or a weight or whatever, and it tells you when you go over a limit.
Yeah. See, it's almost coffee time for me as well.
Yeah, and now I somehow.
How many?
It's 3 p.m.
How many cups have you had so far?
Just one.
If I have more than 2, I don't sleep the next day. Which is weird. Which is weird for someone with ADD, because like normally the stimulant is like all you need.
Did I tell you about the octuple espresso?
Yes, you did many times. Yeah. At least twice.
Of course.
At least twice.
Yeah,
in the last week. Yeah.
Awesome.
All right. So now we have. This is a little weird that there's this little gap here.
Wait. That's where the isolation mount goes?
No, I just picked that gap size to make it look visually similar. Like when you're looking at it from the side, I mean, theoretically, this gap could be almost nothing, right? I mean, you don't want it touching, but it could be our tolerance number, right?
Wait, I'm confused. This rectangle on the left here, that's the side profile of the soundboard, right?
That's the soundboard, right?
And so you're gonna have these sandwich mounts on the left somewhere, right? Like underneath the big circle.
On the right part, right here. They're all under here. So if we look at the original music box, he has these pins coming up and down.
Okay, yeah.
And all of that is between the note machine and the paper puller.
Yeah, okay. But then the dimension of 12.70 you have there, that is actually the size of the sandwich, right?
It is, and those sandwiches will go in here, right? Unless we decide to actually go for the suspended mount sort of thing, for consistency purposes. But I think if our motor is silent enough and we're isolating it from the box and from that, we can use these much easier to deal with isolation mounts in those areas. So the only reason I used that dimension there was so that the gap for the soundboard visually was the same top to bottom as it was right to left.
Yeah.
That's the only reason.
Good to me.
And it's yeah, Jorn, I know they might be too rigid, but we're gonna test all this stuff, right? And actually, you can get them in a bunch of different durometers. So
consider ordering this note box just so that you can screw around with it.
Yeah. Set up a GoFundMe or something. It's gonna be really popular when my wife sees, like, you bought that for what? Like, oh, so I could test it.
Well.
So I don't know why am I adding these lines on?
We have to buy the parts eventually, right?
Well, if we actually make it, yeah.
Right. Yeah.
I haven't mentally committed to actually building it.
Right. Yeah. Well, it's aspirational, right? You have to say that you're going to build it. Otherwise, the CAD is,
Come on, why can't I offset those?
Uh-oh.
Because 10 is way too much. Maybe you should make it less. Select chain. Oh yeah, 10 is huge. Make it like 5. Oh wait, no, that's 100.
Why is it doing that? I don't know.
Oh yeah. Oh, that's weird. Yeah, it doesn't like your.
The question though is, do I need to? I think I do, because I'm going to be setting the locations for the vibration mounts here.
No, the problem is though, if you use springs to do vibration isolation, they don't actually isolate vibrations, right? You have to have something that damps the vibrations, like, rubber or felt or something.
Yeah.
I'm going to do something just disgustingly unaesthetic.
This sketch is very aesthetic.
Just draw another box. Wait, what's the problem with that? That's aesthetic.
I don't know, but it just gives me those center
No,
lines.
no, wait. Is it going to have the same ratio as the outer box?
Yeah.
If you want it to be offset,
okay,
I don't
great.
think that you want it to be. Oh, okay.
Awesome. Then you only have to dimension one side then.
Yeah, I'm trying not to have 15.
That's the plan, yeah.
That's cool. Andre, have you been making extensive use of the centerline feature in Fusion?
I love it.
I haven't really done a ton of Fusion modeling the past few days. And no,
What have you done?
Oh, they have it in Fusion now?
Yeah.
Oh, I was gonna say I've been in the SolidWorks stuff I've been doing. I've been loving it. I didn't know it was a isolation mount stud diameter.
I'm pretty sad that Martin destroyed that thing from the from the conveyor belt, because I just finished redoing it, so I was driven by the skeleton.
Oh man.
But yeah. It wasn't that much work, so I'm not that sad,
but still cry.
All right, so those are our isolation mounts.
All right, question: why is it a different distance from the top than from the side? I mean, I know why. Because you drew the same rectangle, but the question is, why is that like that? Because it feels wrong to me. I feel like it should be just opposite.
Yeah, it's because
both sides the same.
Because you put it on the same diagonal.
I know I put it on that same diagonal. Yeah.
That's why I asked if they were gonna have the same ratio.
Yeah, I thought that would look good, but it didn't.
No.
It's okay, it's easy to change, I guess. Oh, you did it there, so.
But you know what? I need to have this one be the same as this one.
Yeah.
Okay. What safety factor is my bracket gonna get? Who wants to bet?
What bracket?
It's a motor bracket for holding in a.
Yeah. How else would you do it, Jorn Vogels, without doing a second dimension? I mean, I can think of many ways. I'm just wondering what you were thinking.
You could put it at a. Well, you could add a
line between the two vertical lines midpoints.
Yeah.
Does that make sense?
No. You can. I've done it with only one dimension before, where if you want it to be
if the offset feature was working correctly, it would be that. But for some reason, that borked on me.
No. What you do is you establish a 45-degree line by making the line symmetric to both sides.
Oh yeah.
So that's disgusting, and then you put it on there.
Yeah, this sketch is pretty gross, but it's working.
Yeah.
I was thinking you could do two construction lines to the two edges from one of the points, and then just make them equal. But I don't know.
Yeah, you could do that.
Any nicer.
No, that works too.
I'm not sure what Jorn Vogel's type. Horizontal construction line between two vertical lines midpoints. I'm not sure that would solve it, because we do have the midpoint of that rectangle that those holes are on in the right place. We just need to have the aspect ratio right.
I just unilaterally made it deeper just for the aesthetic purposes.
Yeah, it looks good.
Hey, my simulation is done. Oh, it didn't get torn to shreds.
So those larger circles, Tim, are the rubber part of the sandwich.
Yep.
Cool. Yeah, man, this is starting to look pretty good.
Yeah. So let's make a part now. So this is our skeleton, right? We're okay with this as a skeleton, and it shows up,
yeah,
right?
We should. Here's an idea for you. You could do the other profile, the front side.
Okay, let's do that. But let's do it through the center line. I'm going to define a plane. And for some reason, I don't know why it doesn't turn on your planes automatically.
Oh, yeah, good question. Well, you can... Oh, no, it's because... Well, yeah, I'm not sure why, but you can definitely click on the little drop-down next to where it says Music Box Skeleton to see them.
Oh, I just turn them on. Turn them on there.
And 2, 3,
it's all good. So let's do our sketch here.
Man, I just do it on the front plane. What's going on there, Eric? You okay?
I'm counting.
Well, that's pretty weird.
Calling my counting weird?
Was that counting in Spanglish?
Yeah.
No, that was in Swedish.
That makes sense.
All right, so this guy and that guy are gonna be horizontal.
Tim, you're gonna be fluent in Swedish by the end of this project.
I can make it all the way through IKEA, you know, and not pronounce anything correct.
Yeah, no.
All right. First, right here. So this guy. So now I'm just kind of like picking geometry. Convert entities. I pick like that guy and that guy, because those are the side plates. Right.
When I first switched to Fusion from SolidWorks, I really hated how the project feature worked, but now
you like it.
I feel like I like it, and I don't like this method. Yeah.
Well, I mean, it's not just projecting; it's a bit more vague than that. But, I mean, yeah.
Do we have motor plate depth?
Motor.
Because the problem with the SolidWorks method is that you can't tell what is being projected sometimes. Like, you can't tell what you're dimensioning off of. I had this problem when I was looking at some of David's sketches. He had done a sketch and he referenced another dimension and I couldn't tell. So I was like, why is this thing not have a constraint? Oh, it's because it's actually coincident to something in a different sketch. It was pretty weird.
Have you had that bug in Fusion when certain dimensions get hidden? Like in the same sketch.
That sounds familiar.
Half of the dimensions will just disappear.
Oh, I've definitely had like the whole sketch disappear, and that was super annoying or like all the dimensions disappear, and then I had to like.
Yeah, it's just solvable by
close
flipping
and start over.
No.
This is paper width.
You just so you know the palette thing where you choose what to show. You can just double click the checkbox for hiding the dimensions or showing dimensions, and that like re-shows them.
Close paper tolerance. Oh, maybe if you do without a quote, will it give you the search if you do it without a quote? I think it will. Yeah.
Probably. Yep.
Enter.
We're good though. For some reason, my 3D mouse is not working, and I don't feel like troubleshooting it right now.
Oh yeah, that's annoying.
Does that happen to you? Like this die just not going to work? You have to like reopen the 3D experience thing, or okay, so that's good. What else do we need to do? Oh, so those are the motor plates, and then we're also going to have side plates for the here I want the auto constraint.
No, Joran, I think the tolerance is total, not edge to edge.
Yeah, that's total. That is what I meant. I intended it in terms of how much wider is that slot than the 70. Yeah, it's not a one-tailed side. All right. So this is Isolation mount thickness.
And I mean, 250 micron is still pretty big.
Well, when you say to microns, yeah.
Yeah.
That's right.
I mean, what is that in angstroms? It's enormous in angstroms.
That's right.
You're funny.
Planck lengths, man, that would be really big.
Yeah. How many cesium
milli
nuclei?
furlongs.
Yeah. Do I have a thickness for?
Yeah, I guess you could just do only one side and mirror everything.
Box body plywood thickness. Look, I thought of everything.
Truly, you are very forward thinking.
I had one.
Oh, what
guy.
did I not do right here though? I didn't do. Anyway. Yeah, so go ahead. Funny guy.
I had one funny guy at our metal workshop, and he was
that's good.
only one. Yeah, only one.
Sweet.
Nobody else is funny. And he was doing his feed rates in. He was putting in his feed rates in. What was it? Oh yeah, chains per micro fortnight.
Yeah,
that's not that funny actually.
It's roughly
really
0.09 inches per minute.
Okay, wait, but don't you want those outer squares to be longer so that like the box is closed on the bottom?
It's a good question.
Yeah, so make them longer by the material thickness.
No, well, so no, I want the so the idea is that these two planes, you sit this whole box on a thing and you put the aluminum, the motor pulley in, and it lines up because so it will be open on the bottom here, and not in this plane, but this guy will be the same. It's gonna be the same as this guy. No, it's not.
Oh god.
No, it's not. It's the same as this guy.
Oh god, there's no there's no more files in assembly 118. It's all gone.
The Eric and Andre CAD, did you see that?
Yeah, it's good.
It's you guys could be a. Oh, I'm gonna show the let's just show the stream that's. Yeah, it's what is it? Who's playing the Marble Machine original video?
Not me.
I can hear it. Oh, it's in my room. It's some other people in my room. Same guy. I was
coming from inside the house.
Inside the building. All right. So that's. I don't know if this makes any sense, but at least that is. I mean, I can do this if I exit that, and now I hit in a new part. Oh no! I need to insert this into an assembly now, right?
I hope people get that my name isn't
that.
actually spelled with a U.
When are you thinking of ending this stream?
At on the hour, so yeah, in 15 minutes. But I mean, this is good, right? Because I mean, what we're after is competent ways of managing the skeleton sketch.
Yeah.
Right, and we've done that.
You put this in here, and it's going to move around now, right?
Can you save this to the comment space, by the way?
I can. It says, well, it's the Music Box project, and you have access to that. So
it's already in there.
Oh no, because it's fixed. Yeah, I see it.
Yeah, so it's fixed. So the first one comes in fixed. Now I don't know where's the origin. I don't want it there. I want this. I want to float this bad boy. Of course, I can't do that.
No.
I have to.
Why does it matter where the origin is?
Because it matters.
Oh, you do need to make it the same as the skeleton sketch to make it good. Yeah, man. Whatever's happening with your scroll bars here is.
It's because I'm in my smaller monitor and it thinks that so here origin and this point. Oh, that was nice. All right, how do I do this? Fix.
This is skeleton stream free.
Oh yeah.
Oh.
We're good. All right, now this guy is not moving anywhere. Our skeleton, our origin of our skeleton part is the same as the assembly origin, right? We're golden.
Hey.
We could just walk away now.
Yeah.
No?
We have achieved.
We have achieved. All right, so actually, let me since we've done that, since we are feeling cocky about it,
put the music box thing in here. Yeah.
Yeah.
Yeah,
it's okay. Insert components. Insert components. Browse. Apparently, this is supposed to work once you have everything loaded. Loading.
Oh yeah, wait, yeah. How does that work? What do you? Yeah.
Well, so there's a design issue that I want to music stream idea version. There we go.
Yeah, my question is, how do you constrain it? Because the music box
doesn't
have any of these
that's
same
not the right
lines on
thing.
it. I guess you could use mates.
Oh, Tim,
I killed
tainted.
it. You've tainted the file with your educational version.
Yeah.
Well, yeah, we all know.
We need an
ongoing problem.
We need a we need to add a token to the jar. I just crashed SolidWorks.
Oh yeah, I don't have the jar here. We need to let Maureen
know. Wait, I hope you saved it.
Well, we did when the new assembly. I think that whole reverting things to origin. No, so but there is a thing, and I do want to talk about this in our next stream for sure. So after the stream last week, Ace Crystal was in Discord, and I was chatting with him, and we were talking about this issue. Let's see. Oh, I need to wait for this thing up here to load. This issue of like, is it possible to, like, if we do a really good job engineering this thing, is it going to end up losing its soul? Right?
Oh, that's true.
Yeah.
It has to be somewhat horrible.
Yeah. That's the thing.
I don't think so because I think that the soul comes from what it looks like, and even if we engineer it, we can still make it look cool.
Right. So, but so like, let's say like if it's really well engineered, right? But you know, if you do like ornamentation that's like non-functional or ornamentation, then it's like steampunking, right? It's kind of like, I'm not a fan of non-functional ornamentation, like putting like greebles on it, right?
Yeah.
And you know, Martin's first machine was cool because he's obviously a musician and not an engineer, and he still pulled this thing off, right? Like that's kind of like part of the wow factor, right? Now he has 130 something engineers helping him, right? And so like if we really wanted to just like make it super reliable and you know use off the shelf, you know, off the shelf parts, we could make something. It would be kind of boring, right? And you know, kind of when we had our meeting with Martin on Wednesday, you know, he was like, "Oh, we need to do this engineering," and my comment to him was like, you know, the first engineering principles version of the Marble Machine is a MIDI keyboard, right? If all you want to do is make music using a bunch of different instruments, you would think we have like a refrigerated box back there. Like my buddy Jake is fully bundled up inside. It's not that cold here.
Yeah. Amazing.
But it's oh look, I found it. Music Box Skeleton Stream 3.
Yeah, I mean, I think it is a concern that we could over engineer it in that way. So we just have to keep that in mind. I think in some ways, like
I don't know that I saved it. Look.
Like Martin's new approach to having these like plywood rectangular marble paths is sort of in that direction, actually.
So yeah, I mean it's a sound-ish design in comparison to the early ones.
But I mean, I guess if that, the question is, what is the Martin aesthetic? Is it, you know, bad welds and burnt felt, or is it like the sort of whimsical appearance of the entire machine? But it still works, and I think that the second one is more sort of like, you know, wholly good as opposed to like amateurish. I don't know.
Yeah. So I have some bad news. So this is the correct file, Music Box Skeleton Stream 3.
Oh no, is it empty?
It's dead empty.
Yeah.
I mean, this is we were gonna do this anyway.
I don't know.
Now's the time to quit.
I was I was kind of thinking we were going to keep this version.
That's well. Nope. Now you know what it looks like, so you can easily just redraw the whole thing.
That's true, and it'll take less time.
You don't have
and we've learned things about how to do the dimensioning. We've learned about the path length sketch thingy, which was awesome.
Here, I don't have the jar, but I can make the sound.
Oh, thank you. Does it always have to happen, or can you set it up to automatically save in the middle of stuff?
Yeah, no idea.
I wish I
could open my SolidWorks, but it's not gonna work. So.
The with Fusion, when Fusion does crash, which does happen,
right.
You've saved your stuff is saved.
Yeah, it's got the
There's got to be an autosave feature. Okay, well that's on the to-do list.
The autosave feature because of the whole SolidWorks connected thing. Because now it has to be linked to whatever.
Well, you're never using this thing offline anyway, right? So
yeah.
It's
like that when the Xbox Live first came out, and they were like, "Oh, you can only use this if it's connected to the internet."
Yeah. Autosave. Oof. No matches found. Screw off. You can't autosave. Okay, but anyway, so let's. I'm torn between the interesting conversation about how do we decorate this thing, and trying to deny the fact that we just lost everything we did, because I do think we had a decent sketch there.
Yeah.
Guys, so we did a secret Santa with the engineering team earlier.
Okay.
Last year.
Okay.
And so I sent this package to the Netherlands, right? But the delivery failed.
Okay.
The door-to-door delivery failed. So they had it at like a supermarket just 5 minutes away from Fox, and they didn't tell him that it was there, or me, and now it's being returned to Sweden.
Nice.
Sucks.
So I made a visual gauge. I think I showed you guys this visual gauge that I made for Martin. And
yeah, that's right.
And I sent it to.
It never got to him, did it?
It never. It got back to me, and then it's someplace in my shop. We just moved into this facility, and I still don't have. There's a whole other suite which we don't have yet, which is next door to this one. So like in a month, you'll be able to see through this door, and you'll see another door into another suite on the other side. But because we don't have that extra suite yet, everything is just a mess, right? We've kind of halfway moved, but we don't have like all of the space. But like, like the 3D printers are already here, the laser cutter is here, but my CNC mill and lathe are still at the old. Anyway, it's like being halfway moved, which sucks. But yeah, so Spalding, which is that gauge, is somewhere in all of that. Martin still doesn't have it, and when I find it, I will send it to him. But
okay.
All right, so I'm going to cry and rebuild this entire thing, and you guys don't have to watch that. But
well, yeah, this is this is the SolidWorks grind, man. This is how it is.
What I should probably do though,
having to rebuild it from scratch, it's well known.
Yeah, we could do a speed challenge. Like, how long would it take?
Stream. Just like go as fast as
Yeah. Well, here we have, idler roller, working diameter. Now that I don't have to play with all the things that we had done before, you could almost time and say, okay, what's the drive roller working diameter? How fast could he do it? What took us an hour and 0.75 minutes, hour and 3/4. How fast could he do that now?
Yeah, like the learning curve, like they just have monkeys perform the same task
Right.
after, a delay, and then just see how much faster it takes them.
Yeah. Yeah.
SolidWorks, Dassault Systems is the researcher, right? And we're the monkeys.
Right.
Mm.
All right. Well.
Yeah. All right. So I will do this.
I think we've done some good work. I think that this skeleton thing is the right way to go here. I'm excited.
Yeah, we're making good headroom, guys.
What we're gonna do
headway,
next.
not headroom. Headroom is something else.
English is not my first language.
It's okay. We'll keep correcting you until you get it right. Not awesome. Like any of us can speak any other second language. I have I had a roommate in college. Not in college. We both graduated from winemaking school, and we're living in the same house while working together at the same winery. And she had a joke. It's like, what do you call someone who speaks 3 languages? Trilingual. 2 languages is bilingual. 1 language, American. And it was, I couldn't say she was wrong. But
the thing is, America is a pretty big country already. United States.
Yeah, you
of
don't.
America
You can travel. You can travel a lot and still be in the same country.
Right. Yeah.
Yeah. If you're from California, it should be by law that you need to speak Spanish because that's actually useful. In high school, I studied Russian, which was like cool because I got to go on a Russian exchange and live there in Moscow for a little while. But
I speak Russian.
Speaking Russian is not that useful in the United States. And because there's no one around to speak Russian with,
it degrades.
It's completely degraded.
Everybody. We have a ton of. I mean, a ton of like international students at the technical college, but like they all prefer to speak Swedish.
Yeah.
Because they make an effort to learn it. So
yeah, same here. Like if you meet international people, they're all trying to speak English so that they can get better at it.
Yeah, or they'll get berated for not speaking English.
I don't think that happens really, but.
Oh, okay.
All of the variables that I had to put in, I now have to re-put in. But now that I know the shortcut for putting them in as global variables, it's going to be a lot easier.
There's only like a few that we had to do that with, right? Like 3 or 4.
Yeah.
Because most of them were already in.
Yeah. All right. It is 3 p.m.
The text document didn't get ruined.
Yep.
So,
yeah. So we have at least a working understanding of of making a skeleton. So next week we'll talk about some design decisions. We had talked about maybe putting in planetary gears in the paper thing. I'm going to, in between now and then, going to redo the skeleton and draw some of the basic parts that are based on this design. And then we can next week talk a little bit more about the function and some of the secondary design characteristics, try to make it look interesting. Sound like a plan?
Sadly, Maureen's not here. Her main idea was to try to involve the community in the design of this thing. So what do you think about that, Tim?
Well, the community is here.
Yeah, the community is here. We have,
Joran.
We have Joran.
Thank you for hanging out with us.
We have Thomas Nelson over here.
Yeah.
Who else is in the chat here? I don't know how to see everybody who's in the YouTube chat.
At least we don't have 0 viewers, right?
Right. Thank you. Yeah. Well, even if that's why I like having other people on the stream with me, is that even if we had 0 viewers, at least I'm hanging out with 1 or 2 people. Right?
Yeah, you're not just sitting here.
It's not like you're just talking to the universe, right?
That'd be sort of sad.
It would be sad. Yeah. Yeah.
Oh yeah, you're going to be cashing in those fame credits, pretty soon.
Yeah.
Here's the thing: if you guys want to post stuff in the CAD Team Music Box channel about what you think this thing should look like, if you have ideas that are different from Martin's design. For example, one thing is for mounting the paper spool, right?
Mm-hmm.
Like we have the whole like frame object that was in the Martin's version of it, which kind of looks like the MMX frame, but like I don't know. What do you think about what we're gonna do with that?
Yeah, I'd love to see some ideas there. You know, we still have some engineering stuff to talk about as well in terms of like motor sizing, etc.
Yeah.
I think we skipped past this by parameterizing
everything. Yeah.
everything. So parametricizing.
Yes, that's the official term.
Parametrificating.
Yeah.
No.
That's
parametrification.
Yeah. Parametrificate. Okay.
Yeah.
Anyway, so we're moving past that, but so I'm gonna redesign that. Let's look for some ideas in terms of how we like make it visually interesting, and then we'll go from there. We'll take it up again this time next week.
Yeah.
Yep.
All right.
Sweet.
You guys, Eric and Andre, thank you for hanging out with me. Thanks for everybody who is watching on YouTube. Appreciate it, guys. And yeah, we'll take it up next week. Cheers, guys.
Have a good rest of your day, everybody.
Ciao.